Yo, what is up, guys? Welcome back. Episode 104 today. We got a Cubone today. Let's take a listen to the sound. Cubone sound. Let's take a look at this. Cubone. Cubone. Take another listen. Cubone. Cubone. One more. Cubone. There we go. Take a look at a quote today to get started. I'm feeling definitely better today. I was just a little foggy yesterday. I think I was tired, so I did have a late night the night before. Went to sleep pretty late, so feeling better today and ready to crush some problems. So let's take a look. This is a good one by Steve Jobs. What an interesting one. If you're working on something that you really care about, you don't have to be pushed. The vision pulls you. Wow. That's pretty crazy. That's a good quote. I really like that. If you're working on something that you really care about, you don't have to be pushed. The vision pushes you. The vision pulls you. So you see what's out there, and you want to accomplish that, and it's pulling you. So that's a good one by Steve Jobs too. We'll read it one more time. If you're working on something that you really care about, you don't have to be pushed. The vision pulls you. Interesting quote. Oh yeah, let's take a look. Let's jump into putting our problems today, see what we got. I don't think we ever did letter combinations of a phone number, so how about we just jump back to some backtracking? I don't think it hurts. I know we have solved this before. Oh no, we did do this. Yeah, my bad. Yeah, we did this a couple days ago, about a week ago. Yeah, cool. So we did do that. So let's got some DP problems. Number of directed opponents and undirected graph. How about we take a look at that one? I don't know if that was a premium one. Maybe we can do that and take a look at some DP. Number of connected components. Components. Yeah, that's a... Oh wait, is it? Yeah, it is a locked one. Premium only feature, bro. Damn. Oh my god, I'm gonna sneeze. I'm gonna sneeze. Oh, bless me, bless me. Oh my gosh. Ugh. Let's take a look at meeting rooms. Oh, I think this is a premium one actually. Bro, so many premium problems, bro. Like meeting rooms? Yeah, it's a premium problem. Bro, dude. Let's take a look at insert interval. We'll take a look maybe at an interval problem. I think we have. No, we haven't done this one. Take a read. This is the first interval problem. You're given an array of non-overlapping intervals where intervals I is equal to start end. Represent the start and the end of the ith interval, and intervals is assorted in ascending order by start. You're also given an interval, new interval start end, that represents the start and end of another interval. Insert new interval into intervals such that intervals will be sorted in ascending order by start, and intervals does not have any overlapping intervals, merging overlapping intervals if necessary. Return intervals after the insertion. Okay, we got to return a list here. We want to return a list inside of a list, so I'm a little confused here. 1 3, we got 2 5s. Our output is 1 5 6 9. You're given a non-overlapping interval, intervals where intervals I is equal to start end. Represent the start and end of the ith interval. In intervals, and intervals is assorted in ascending order by start. Okay, we can see that, right? See that right here? 1, 6. It's ordered by start in ascending order. You're also given an interval, a new interval, start, end, that represents the start and end of another interval. Insert new interval into intervals such that intervals is still sorted in ascending order by start, and intervals still does not have any overlapping intervals. Merge overlapping intervals if necessary. Return intervals after the insertion. Note that you do not need to modify intervals in place. You can make a new array and return it. Interval 4, 8. 1, 2, 3, 10, 12, 16. Because the new interval 4, 8 overlaps with 3, 5, 6, 7, 8, 10. Bro, how does it overlap? I'm a little confused with the question. Mirror turned out to be every failed test case 608 piece of your soul. I don't really understand the question, to be honest. I don't feel kind of stupid, but so interval, can you help me understand the question? Non-overlapping intervals sorted by their start times. A new interval is to insert. Your job is to insert the new interval into this so it remains sorted. Merge any overlapping intervals if needed. But how is it overlapping? One 3 and 2 5 overlap. Merge to 1 5. How does 1 3 and 2 5 overlap, bro? Like, what? A2 is greater than or equal to B1. B2 is greater than or equal to A1. Oh, they both share the range 2, 3, so they overlap. Ah, okay. 1, 3, 2, 5. One second, guys. My buddy's calling me. I will be back in a second. Okay, we're back. Let's take a look at this. Okay, 2 intervals, A1, A2, B1. Overlap if. Okay, so here, go, okay, 1 to 5, 6 to 9. We've got 4, 8, right? So we would delete 6, 7. We would delete, well, they share an interval with 8, so it would have to be like 3. It would be 1, 2, 3. 1, 2, 3. 10. 12, 16. Ah, okay. Okay, I understand. Intervals arrays sorted. Can you use binary search to find the correct position to insert the new interval? Can you try merging the overlapping intervals while inserting the new interval? So obviously we'd have to loop through, right? So we'd have to loop through all these numbers and check, okay, well, if B is less than A, right? New interval is a list, and then we have a list of lists, right? So if we go, okay, well, for interval in range intervals, let's print the interval, right? These fucking retards, okay. Interpreter is an integer. Did I spell it wrong or not? Okay, we need to do, okay, let's do AB is equal to interval. Alright, and then we print A, print B. But it cannot be interpreted as an integer, bro. What? Oh, it's the range function, dude. I think that's what it is. Okay. Let's do... I think we might need the index, right? So let's do like interval index. Okay, there we go. For no way. Okay, so we have our intervals now, right? So what we want to do is okay. Okay, we want to go AB is equal to interval. And we want to loop through and we want to keep checking until, I don't know, do we use binary search for this? Intervals array sort of can use binary search to find the correct position to insert the new interval. I might get a TLE. I'm just going to do I'm going to think about like the brute force solution, then we can think about optimizing it. Just kind of making it work, because at the moment, so we need to check, okay, well, if So I think we need to check, well, right, so the thing is here is that we pretty much have to create a whole new interval, right? Like, we're actually implementing 2.5, so now I feel like we can keep looping through until we see A, right? Put A in. Right. See, I just don't know if this will work though. 4, 8. Okay. Let's do start end is equal to new interval, right? So if start see, I just don't know how we can compare this, right? Because everything's going to be lower than it. I guess we got to somehow like look for the max value, right? So we would have to somehow loop through and check, well, okay, well, if A is less than start, right? Let's kind of find the location, right? I guess that's our first step, right? We have to find the location where this happens, right? So we go, okay, well, we want let's call it like new start, right? New max. Can the values be negative though? From 0 to 10 to the power 4. So the values can't be negative, right? So we would go, okay, well, let's do like, let's call this something different. Let's call this like new start 2. If A is less than start, then we would go, okay, well, new start. Technically, it could be any, right? It could be so we loop through and find the first number that is the greatest number that is less than 2, right? So that's here, right? Let me say, okay, well, this is where we begin, right? This is what our new start would be, right? I believe, sorry, let's make this new end, right? And then we keep looping through and check, okay, well, where is the value above it? The first value above it, right? And that's this one here, right? So we get these two values, so we know that it's in between these two, right? And so what we want to do, sorry, we know that it's the first value that's bigger than it, right? So it'd be these two, right? So we get these two values, and what we want to do is we want to make it roll one, 5, 6, 9. And new start is equal to A, right? Let me check, well, if B is greater than new start needs to be float inf, right? New end can be 0. That's fine. So let's make it -1, right? Because it can't be -1. So if B is greater than new end, we can actually just, I guess for practical sake, we can just make it -infinity, right? We can do, okay, well, if B is greater than new end, then new end is equal to I guess it could be A or B technically, right? So it's like if A, still if A or B, if A is less than start or B is less than start, and we make let's make the index, right? Let's do new start index is equal to index. I don't know if this is needed, but I'm just gonna keep track of it anyway. Let's do new start index is equal to 0, right? New end index is equal to 0, right? If B is less than end or A is greater than new end, then let's do new end is equal to, oh shit, we can't do both. I guess this is always going to be A, is it? Technically? I don't know, dude. Let's just make it B for now and see what it does. Maybe U1 is equal to B, U and index is equal to index. Let's take a look here. Let's print our new start and print our new end, right? One nine. I guess in this case here, this one could be A or B. If A we'll have to make an else if here, I think. B is equal to greater than new end. Else if A is greater than new end, then new end is equal to a u end index is equal to index, right? Do we need to check this? We need to check some sort of max, right? So if we need the one that's less, right? So if new end is less than B, right? Then we'd want to append it, right? Let's see what that gives us. Here we get 1.9. We want the 6 here though. We got 4.8 here. So we got 3. Bro, what is this, dude? I'm gonna take a look at the I kind of just want to get this working. What am I? Oh shit, we got the oh shit, no, grader. We got the first one right. This is correct. I know this is correct, right? We're getting the right interval for both the test cases, 3 and 1, right? This case here, we need 8. We need to return 10, right? So if oh, I'm not checking the right one. $16 still. I think we have to check these independently, not the else if. Maybe we have to check the A first, I think. If A is greater than end, right, which in this case it is, it's because it's the float. Let's get rid of this if right here. This isn't going to work, right? Because we're going to get the most maximum value here, right? We should get the most maximum value. Okay, 16, right? Now if we... But if A is less than... We're not guaranteed that A is going to be less than UN, right? Because it could be B. Or do we want the first value? Yeah, dude, I'm going to have to watch this video. I've got no idea.
3 ways Google's Notebook LM helps me study for finals. First, it stores all my study materials in one place, from notes to text.
Hey everyone, welcome back, and let's write some more Leetcode today. So today let's solve the problem insert interval. And this is actually another problem from the blind 75 list, a list of 75 common Leetcode questions that we've been tracking on this spreadsheet. We're almost done with all of them. Today we'll be solving this interval question, insert interval. So basically we're given a set of non-overlapping intervals and we want to insert a new interval into this list of intervals. We want the intervals to remain non-overlapping, so basically we might have to merge some intervals because we are given a single interval. We're given a list of non-overlapping intervals, in this case 2, 5. So when we insert this interval in here, you can see that 2, 5 is an interval, right? Suppose we have 1, 3, and then we have 2, 5. So clearly these two intervals overlap each other, right? So then we have to merge them together. How are we going to merge two intervals together? Well, if they are overlapping, we're going to take the minimum of both of them. In this case, it's 1, and we're going to take the maximum of both of them. In this case, it's 5. So that's what the new interval is going to be, right? So we merge them together. We'll have a new interval like this, 1, 5. And so this is a new interval. And then you can see we have another interval, 6, 9. Now 6, 9 is not overlapping with 1, 5. So in our output now, we're going to have two intervals, right? We're going to have 1, 5 and 6, 9. And then we're going to return these intervals in the output. Now, the convenient thing is that these intervals are actually already sorted for us in ascending order based on their start times. That's good because that means we are not going to have to sort them. And if you've solved any interval problems before, you know that sorting always comes in handy for interval problems. And I don't know if they specify in this problem, but just so you know, an interval such as this, let's say we had 1, 2, and another interval 2, 3, these do count as overlapping because these 2 points technically are connected. So this would be one single interval, 1, 3. I don't know if they mentioned that somewhere in the description, but that is just an edge case that we'll have to keep track of. Suppose we were given a list of intervals such as these, right? These are sorted in ascending order based on their start value, so none of these are overlapping, which is what we expect. What if we were given an interval such as this one, an interval that actually goes, let's say this is, 1 second.
put on the laundry. Jeez.
0, right? Even though I don't know what kind of interval would end at 0, but let's just assume it is, right? So that it doesn't overlap with this one. So since even this interval, right, the end value is less than the start value of the first interval, that means this interval is not going to overlap with this interval, right? And if it's not even going to overlap with the first interval, then there's no way it could overlap with any of the upcoming intervals either, right? So when we basically return our output, we're just going to return this original list, but we're going to add this interval at the beginning, right? So that they're still in sorted order and they're non-overlapping. Now, what if the opposite was true? Suppose we were given an interval such as this one, 7 to 8 or something like that, right? Where the start value of this is actually greater than the end value of the last interval, right? In this case, this interval won't overlap with any of these, and then we can just return the original list and adding this to the end of the list, right? Now, those are a couple of the simple cases, but it's possible that the new interval could actually end up overlapping with one of these other intervals, right? And then we'd have to combine both of these. It could be possible that the interval actually could overlap with multiple intervals in the input, in which case we have to combine multiple intervals, right? Or it could be that the new interval would actually go somewhere in between a couple of these and not overlap at all. So how are we going to determine where exactly this new interval ends up going? Well, we'll have to iterate through these sorted intervals and then basically find the insertion point of the new interval that we're looking for. So we're going to go, suppose we have an interval like this one, right, somewhere small in between here. We're going to go interval by interval. We're going to see, okay, this is the first interval. Does this overlap with our new interval? It does not. So we would take this, add it to the output. We would look at the next, and we would see that this interval goes after that, and then we go to the next interval, and then we'd see that, okay, this next interval actually goes after the interval that we're trying to insert, right? Suppose we had a really small interval like this that goes in between. Then what would we do? Well, we wouldn't want to add this one to the result first. We would want to take this new interval, add it to the result, and then add this to the result. And then at that point, we can just take the remaining intervals and then add them to the result, and then we can return. So those are a couple more of these simple cases, right, where we would not have to merge. Suppose we had an interval such as this one, though, right? Let's say 0 to 3 or something like that. Okay, we iterate through the first interval. We see, okay, this interval is overlapping with this one. How do we know if they're overlapping or not? Well, we would check, okay, does the end value of the new interval, is it less than the start value of this interval? It's not. Okay. Is the start value of the new interval greater than the end value of the current interval? It's not. So if neither of those are the case, that means this interval does not go after this interval and it does not go before this interval. So that must mean that they are overlapping, in which case we're going to merge them. How are we going to merge them? We're going to take the minimum of the left and the maximum of the right and then merge them together. So when we merge them, we're going to get a new interval such as this one, 0 to 3. And once we have this merged interval, we're not going to actually add it to the output just yet, because we know that this interval could actually overlap with some other intervals that we now have that come following, right? And that's exactly the case. It's overlapping with this other interval, 3, 4. So we've gotten rid of this first interval. Now we're going to be iterating to the second interval. We're going to see 3, 4. Okay, is this overlapping with our 0, 3 interval? Yes, it is. So we're going to merge these as well. We're going to take the minimum of the left, it's going to be 0, and the maximum of the right, it's going to be 4. So we merge these together. So now we're going to have a new interval from 0 to 4, and we're still not going to add this to the output yet because it could technically still be overlapping.
Bro,
with
there's so many
following
edge
intervals.
cases. Like,
in this case, we're going to get to the third interval, and in this case, they're not overlapping. How do we know that? Because the end value of this one, 4, is less than the start value of the interval that we're at. So what are we going to do? We're going to take this, the first interval, add it to the result now, and then we're going to take this interval, add it to the result after it, and then we're going to go to the next interval, see that we don't have any more intervals remaining, and then we're done. So this is going to be our result in this case. 0, 4 and 5, 6 are new intervals after we've merged them and they're in ascending order. So that's kind of the general algorithm. As you can see, since it's already sorted, we'll just have to iterate through the entire list of intervals once. So the overall time complexity is going to be big O of n. That's also going to be the memory complexity if you count the memory that we're going to use to create the result array. With that being said, we can hop into the code now. Into the code, and so we are going to have a result of intervals. And as I mentioned, we're going to be iterating through every single interval in the input. We're given a list of intervals. They're already sorted in ascending order. So now we want to know the couple edge cases, remember? So basically, if this new interval, suppose it goes before the current interval that we're at. So suppose the end value of this new interval is actually less than the start value of the interval that we're at. So how do we get the start value? Well, interval at index I, the 0 value, this is the start value. And so basically, if the new interval has an end value that's smaller than the start value of the current interval we're at, what are we going to do? Well, that means we can go ahead and take this new...
With Remarkable Paper Pro, our meetings are so much more efficient, free from distraction.
Interval and insert it into the result. So we'll say result.append new interval, and once we're done with that, then we basically know that all the intervals that come after it are also going to be non-overlapping, right? So we don't really have to do anything. We can just take those additional intervals, append them to the result, and then return. So in Python, an easy way to do this is result plus intervals, the sublist starting at index I going until the end of intervals, right? So we can just take that entire sublist and append it to result. You can do that with the addition operator, and then we'll just return that, right? We don't even have to continue this while loop. Now, the opposite case we discussed, remember, was else if this new interval actually goes after the current interval that we're at. Well, in that case, that means the new interval could actually still be overlapping with some intervals to the right. So we're not going to add the new interval to the result. Let me write the condition. So basically, if the new interval, the start value of this new interval was greater than the end value of the interval that we're at, then to the result, we're going to go ahead and append that interval that we're currently at because it's not overlapping with this new interval, but we're not going to append the new interval just yet because it could technically overlap with some additional following intervals that are coming up. And the last condition, so these two conditions are if the new interval was not overlapping. But the last condition, else, if neither of these evaluates to true, that means the new interval is overlapping with the current interval that we're iterating through. So what are we going to do? Well, we want to update the new interval in that case, right? We want to merge it with the interval that we're at. And remember, how are we going to do that? Well, we're going to take the minimum of the left value of both intervals. So this is how we can do that. The minimum of the new interval and the minimum of the current interval we're at, and the maximum of the right value of both of these. So let me copy and paste. And the right value is going to be at index 1, so we just have to change those indexes. So this is what the new interval is going to be set to. Now, once we've updated that new interval, right, we basically merged it with a different interval. Are we going to add this new interval to our result? Well, not quite, because remember, this new interval could still be overlapping with some additional intervals that are coming up. So we're not going to add it just yet. And then at the end, so once this entire loop is done executing, we're going to go ahead and return the result, right? But remember one thing. So there's two ways that we could have exited, right? One is that if we ever got to the point where the new interval was, basically if this if condition ever executed, if the new interval was not overlapping with a interval, then we go ahead and add that new interval to the result, and then we return, right? But if that never executes, then we're never going to end up adding the new interval to the result, right? So what we want to do before we return the result is go ahead and take to result.append that new interval before we return, right? Because that means basically we definitely want to append this new interval to the result, right? That's kind of what the function was telling us to do, insert the new interval. So we want to make sure that we do end up executing that. So once that's done, we have written the entire code. And as you can see, it is a pretty efficient solution. So I hope that this was helpful. If it was, please like and subscribe.
So they're tricky, lots of edge cases to consider. Okay, let's try and understand this code and write it. Oh my god, bless me. Oh. Intervals, right? Okay, we can get rid of this because we don't need this stuff, right? We don't even need the index here. Guess we can just keep this for fun, right? We need to declare a res array, right? Now we loop through each interval, right? We check, okay, well, if new interval new interval 1 being this value, right? If new interval 1 is less than intervals I 0, right? So if we're looking at this number, right? If this number is less than the 0th element, so we're looking if new interval 1 is less than I0, new interval 1 is less than the 0th one, right? So we're looping through the 0th ones. 3, 6. So we should print 6 here, right? Let's print test is equal to append new interval. Return res I being the interval. Let's make this I a little bit more readable. New interval 25. Okay, so if new interval 1 so 5 is less than 6 here, so therefore it's going to run, right? Res.append interval return res plus intervals from I to the end. Two, 5, 6, 9. Right, so this is an edge case, right? Else if new interval 0, so we're looking at the first value, is greater than intervals I1. So if new interval 0, right, is greater than this value, so which it is, and res.append intervals I. Intervals I. Then we get the max of new interval 1 intervals I 1. Then after we would simply append a new interval. Turn res. Still not really understanding this in the, I think in the best way I could. I'll close this door, man, it's so loud. Regional checking 3 cases. Case no overlap. New interval is before current interval. The new interval ends before the current one starts. So we can just do res and then plus the rest of it, right? So we would know that it inputs here, right? Case 2, the new interval is after the current interval, right? So we check, okay, well, if new interval 0 is greater than intervals I1, so if our first element here is here, then we just do, well, res.append intervals I. Case 3, overlap. There's an overlap, so you merge into a new interval. You keep updating the new interval in case more intervals overlap. Man, what an interesting solution. It's hard for me to think like that, bro. Like, I was thinking about this case here. You know, I was trying to figure out how we can merge this, right? But it's like, man, I could have thought about it in the 2 other edge cases coming before and after. Really, we're checking the first value coming in here, right? And then we're checking the end value coming after this one, right? If this is like overlapping, right, then we just take, okay, the lowest of this number and the lowest of this number, right, which is 1, and we take the greatest of, you know, this number, and we measure and get it, so 1, 5, right? So what we go through this code here, we go for iron range, like, you know, right, we would check, okay, well, if okay, well, if 0 is greater than intervals I1, Reservation 1-3. 5 is greater than less than 1. No. No, so it's in else case there's an overlap. New interval is now updated 1-5. Second interval is 6-9. Okay. If 5 is less than 6, yes. New interval ends before the current one starts. Interval 1. That's a good way to think about it, man. I would have never thought about this solution, like, ever. This guy uses binary search to find it. This guy uses a lambda function to sort, I think. I don't know. It's definitely a tough problem, bro. Like, I mean, I don't know. I don't even know if it's tough, is it? Like, I mean, I couldn't do it. You know, I had to look at a video about it. What is it called? Insert interval. Like, what is the acceptance rate, dude? 43%. Like, yeah, dude. I wouldn't have got it. Like, take a look at this one again. I know we looked at that a couple days ago, but maybe we can take a look at this one again. I mean, we have our code before. I remember the way we were thinking about this, we were checking with flags. Did this run? Doing a typical BFS, right? Directions for row and call, if BFS row call. Returns true, right? So the BFS returns true, well queue. Take a look at this response, right? So, that's totally fine. Let's go through what might be going wrong in your code. Here's a quick summary of the main issues. The logic, #1, logic bug in this line. This doesn't do what you think it does. If P ocean, A ocean is equal to true. If P ocean and A ocean. Okay, that's what I messed up here. P ocean and A ocean return true. Problem 2. BFS sometimes returns true, sometimes returns. Destination return true. -1. I guess we can go through and just return false. This one's not a bug, but maybe a misunderstanding. This is declared outside the BFS, but you redefined it inside the BFS function. Oh, whoops. We define it inside the function. Okay, so we can get rid of this. Get rid of the rose coals. So we're getting an output of 0, 0, 0, 1, 0, 2, 0, 0, 4, 1, 1, which is here. I thought we don't include edge cases. We get 1, 3. We get 1, 4. We didn't get 2, 2. Okay, that's an issue. 2, 2, 3, 0. Nope. 3, 1. Nope. 4, 0. Yeah. Whole queue. Row call. Return FP ocean, A ocean, return true here. We loop through our neighbors, right? So for DR and so I don't think we're checking any like I guess we'd have to check, right? So well, if our new row we're not checking anything here, right? So we're starting here. We just keep calculating, right? Like if the new row just checks if it's in bounds, right? We have to first check if it's in bounds, right? So check, well, if okay, if new row is less than row, Then we can append, right? If height's new row, new col is less than height's row col, then we can append, right? If not, we don't. Is it heights? List indices must be integers or slices, not tuple. Oh shit. Whoops. Row call. Okay, that's better. We get 0, 0 here, but now we get 0, 4, 4, 0. What is wrong here? What is 4, 0? So if we go 4, we go 4, 0 here. Or we would go 0, 4. 0, 1, 2, 3, 4. 0, 4 is here. 0, 4, and then 4, 0. Gets both. If we went here, oh, we need the equals too. Okay. Why is this an incorrect check? This line is reversed in logic. You had correctly implemented the outer for. Oh, we are already checking it. And height's row call is less than or equal to new row, new call, and new call not invisited. Oh, okay. We already check it here. If height's row call, shouldn't it be the other way around? Shouldn't the new one be less, technically? Ah, there we go. Okay. Wow, we were close the other day, but this is going to get a TLE now. 100%. Oh, no, it's submitted. Oh, wow. That's impressive that it's submitted. What's the fastest solution? Surprised that's submitted, bro. Like, what would be the faster way to do it? Well, we go from the cols, right? We would loop through each column. Fastest way for this problem. Reverse BFS DFS from the oceans. Instead of trying BFS from every cell to the ocean, which is slow, flip the logic. Start from the Pacific and Atlantic borders and do the BFS or DFS to mark all cells that can flow into each ocean. Oh. Okay, so we start from the borders, right? Because we always know that this is here, right? So that's interesting. So I guess we go well for row and col and range cols. if grid row, maybe can we quickly do this like this? If grid row call is equal to if row is equal to 0, so it would start from 0, 4. So if row is 0 and call is equal to 4, right? Which are the borders? Let's put this in here. Or row is equal to 0, 1, 2, 3, 4. Row is equal to rows, and call is equal to calls, right? Because we do it up here. Calls, and we run BFS. Then we run BFS row call. Maybe we can make this even faster by only doing the BFS from here. I mean, I don't know. It's right. I'll have to change this up a little bit, I think, because we'd have to go, okay, well, this is equal to set, right? Okay, because our directions up, down, left, right. We have to be able to check diagonals too. Right, because we need some sort of condition, right? I gotta go to the bathroom. I gotta go to the toilet. I'll be back in 1 second. Okay, I'm back. So I was thinking here, right? We know here. Oh, my thing just ended. 1 second. I gotta swap the laundry. Oh. Oh yeah, actually, just turn it back on. Okay, so when we were running this BFS function, we were checking, okay, well, if 0 is less than or equal to new row is less than that, and heights new row new call is less than or equal to heights row call, it passed, right? Because we went from each cell, and we did, okay, well, let's go from here, right? We can go 531, 532, right? So what we got to do here is we got to keep track of the original cell's number, right? The original cell's number is less than that. We can't keep checking, right? Because 4 is less than 5. It can never get to this 5 one, right? So we have to keep track of the latest cell at the end, right? So we loop through here, right? I guess technically we wouldn't even need this loop, right? We'd only need to start from here and here, right? So I guess technically we can just call... We can call BFS row call twice, right? And we will call, okay, well, we want our row to be that, to be 0. And then the length to be rows minus 1, right? Then here we would want row to be the length of rows. So the length of, column, row. So our row would be 0, row 0. Our column would be bro, I'm so confused right now. Okay, let's do this later, right? So we call out, we'd only really need to call from here and here, right? So shit. No, we won't actually. 'Cause that won't work, right? We can't just call from here and here, right? Because here, and this is wrong too. I put a constant number here, because we can't go from here, because then this is positive, right? So we'd have to go, okay. Do we have to go from... No. Dude, once I'd be able to figure this out, I would be able to do it, right? But I'm thinking you can't go diagonal, right? So it would have to be like they're going like 5, 4, 1. Yeah, I mean, I could do it from the ocean. I have to really think about it, but... Yeah. I don't know, we'll leave it for now, because I want to get to some more problems, but... Okay, we technically did do that one. So... let's do some... I mean, we got about half an hour left. Let me see... My girlfriend's going to be here. She said that at 12:30. Okay. So she should be here in about 20 minutes. So I think that's time for, like, one more problem, so... Let's do some simple ones. Climbing stairs, right? We should be able to do these two. Right, we have done them before. Let's take a look. DP is pretty much recursion, but with an extra layer to it, I'm pretty sure. So, when did we solve this? We did this Jan 13th. Okay. You're climbing staircase. It takes n steps to reach the top, right? Each time you either climb 1 or 2 steps, and how many distinct ways can you climb to the top? Okay, so n is equal to 2. Go one step plus one step or two steps. N is equal to 3, we can go one step, one step, one step. Okay, so we need a recursive function. Def recursive, right? I guess we want to like kind of like pass in our I or something, right? Okay, so there are either two ways to climb, right? So what would our base case be? Well, we're going to go from the top, right? So 3. We can either go one step, one step, one step, one step, two step, two step, one step, right? So we can go, our base would be, okay, well, I guess if n is equal to 0, right? We can't do anything, we just return. If our n is equal to 1, then we would return if n is equal to 1, we go recursive I minus 1, right? Okay. And then otherwise the recursive case would just be, okay, well, we would return n minus 1, return recursive I minus 1, we can go one step, one step, one step. You can go 1 or 2 steps. So let's do recursive plus recursive I minus 2. I guess we're not calling it. Let's return our I guess we're not keeping track of a count, right? So we need some sort of count. If n is equal to 0, we return count. Recursive count is equal to count plus recursive right? We would return our count. Recursive and count. Count is 0, I guess. I guess we would. I don't even think we need this. We could just return the recursive. Right, okay, so if we were to pass in 2 here, right, it's not 0 or 1, so we would go count plus recursive I minus 1 plus recursive I minus 2, right? I minus 2, we just return 0, so we return count. We would just return like I'll just my girlfriend's here. I guess that's the end of the video. Recursion depth exceeded. Okay. We'll have to finish this another time. But I appreciate you guys watching. And I will see you on Monday. So appreciate you guys watching. See you later.